Hello students, hopefully you've been looking through the other papers I've posted. This is GCSE Edexcel specification computer science paper from 2025, paper 1, and to help you revise I'm going to go through the paper. So let's get started. Data. Alright, binary patterns consist of groups of bits. Identify the largest. Alright, nibble is 4 bits. Maybe 1024 to the power of 2. Kebi is smaller than that, and then 1024 to the power of 3. You've got to remember those. Kilobyte, megabyte, gigabyte, terabyte are base 10. So like 1,000, a million. Just keep on adding 3 zeros. Just remember the pattern. But KIB, MIB, GIB are base 2. This is a base 2, so if we had 2 to the power of 10 equals 1024. So that's a kebibyte, 1024. And then you can have 1024 to the power of 2. So just to give you a bit more context, is to help you revise. So 3, 1024, and you could say 1024 times 1024 is another way of doing it. State the number of unique values that can be represented in 7 bits. Okay, so the easiest way, you could literally just do 2 to the power of 7. So 2 to the power of 7 is the easiest way to say, but it will be 128. Why? Let's just work it out. So if we had 128, 64, 32, 16, 8, 4, 2, and 1. We've got 7 bits, so we get rid of that one. What's the biggest number we can have? 64 plus 32, 96. 96 plus 4 is 100, so 100, 24. Okay, so we've got literally 127. So why did I write 128? Well, because we've got 0 as well. So all the binary patterns are the unique values. The denary, which is just a fancy way of saying base 10. ASCII code for D is 68. So if D is 68, E, F, and G. Like, don't overthink this. And it's simply 71. So 71 is the answer there. Hexadecimal is used to represent memory addresses. Give 2 characteristics of hexadecimal notation. You could say base 16 number. That's probably the easiest, the first one to do. And then you can say uses 0 to 9, and then A equals 1, B equals 2, C equals 3, D equals 4, sorry, 14. Oh gosh, I'm doing this wrong. Apologies, let me just do it again. Sorry, I'm racing. Instead of 10, we say A, 11, 12, 13, 14, and 15. So 0 to 15, so 16 values there. And if you don't know how to, if we had a number, let's just say 57, what's that in hexadecimal? Well, let's just work it out in binary. If we get it in binary, it's easy. So we don't need this one, we don't need this one, we do need this one. What have we got left? 25, so we need this one, that's 48, 48, 56, 57. So if that's our binary representation of it, we chop it in half, and then we look at the nibbles only, 8, 4, 2, 1, and we've got 2 plus 1 is 3, and then 8 plus this is 9, so 39 would be how to represent that in base 16. Yeah, I did that right, didn't I? Yeah. Okay. Explain one reason why programmers use hexadecimal to specify memory addresses. So it's typically used in because it's much easier than binary, obviously, and it's human readable. So hex numbers, I'm just abbreviating here, are easy to read, compared to binary zeros and ones. They are shorter and more condensed. I think that'll be enough. Less prone to error. Audio and image files store data in binary. Explain one reason why lossy compression is used to reduce the file. Lossy, so if you've got a WAV file and then you go to an MP3, you will lose information. So let's just say the WAV file was 40 megabytes and the MP3 was like, I don't know, 4 megabytes. It's sort of gone down by a factor of 10. You will not get that back again. Once MP3s cut stuff away from it to compress it, it is a lossy format. Now, lossless means we can retain exactly the same amount of information. So like PNG files, you're not losing any information. So some frequencies, so you can say some frequencies can be removed permanently. So, you know, anything really over like sort of 15 kilohertz isn't really heard by a lot of adults, actually, and anything under 20 hertz isn't really audible that much. So you can immediately get rid of certain things. Usually 20,000 hertz we can keep, but anything above that we can chop away. And it improves streaming, better for streaming. So think of your Spotify. Yeah, it's because it is much faster. Files moved more quickly. So an MP3 is far easier to deal with than a WAV file. Okay, the image is 315 pixels, 923 high, and the color depth is 70 bit. So what you need to remember is width times height times bit depth. So the width is 315, 923, and 7 is the bit depth. And then what's our denominator? In bytes, divide by 8 because there are 8 bits equals 1 byte. So a bit is just a 0 or 1, and then that's going to be 8 of them. And we're dealing with bits, file size in bits for images. It's the same sort of similar kind of idea with networking where you have megabits per second. Computer systems manipulate bit patterns, identify the result of applying an arithmetic shift right by two or to the binary pattern of 0, 1, 1, 0. Okay, fine. So arithmetic shift right confuses a lot of students. You keep the value of the MSB. The LSB is the one on the right hand side, the least significant bit. So if we had a value, let's just make an example, 1, 1, 1, 1, 0, 0, 0, 0. And if we divided that by 2, arithmetic right shift is usually to do with 2's complement. Okay, it's not explicitly saying it in there, but it's usually to do with that. So dividing that by 2, we have to preserve the value of the MSB. So, I mean, what is this, first of all? This would be a minus value, minus 120, that's positive 64, positive 32, positive 16. So if I have a minus 128 plus 64, I've got minus 64, plus 32 is minus 32, minus 6, so this equals minus 16. I expect that to now be minus 8 if I divide by 2. So how am I going to do that? I keep the value of the MSB, I have a gap, that one goes over here, that one goes over here, that one goes over here, 0, 0, 0, that one goes over here, gets chopped away. I haven't lost any information, it's not a problem. So the only way I can get a minus 8 from this is if I fill up the gap with the value of the MSB. So now I have 128, minus 128 plus 64 is minus 64, plus 32 minus 32, minus 16 plus 8 is minus 8. That gives us our minus 8. If I divide it again, then it would be minus 4. I have to put the 1 in there. So that's the best way of just checking your answer. So if I've moved this over by 2, I'm going to get rid of those 2 zeros. And if you've got a 0 on the MSB already, it's a positive value, and just keep the value of the MSB. So already I've got to look at the one that's got two ones at the end of it. All right. So it's if I've got a positive value, I fill with the value of the MSB. Usually these questions have a 1 on the left hand side. Usually. Convert the denary value, a denary number 25 to 8-bit binary. It should be pretty easy. So just mark them all out. 2 to the power 0, 2 to the power of 1, 2 to the power 2, etc. And then just work through elimination. Like, do I need 128? No. Do I need 64? No. Do I need 32? No. Do I need 16? Yes, I do. I need an 8, 24, and a 1. That's all I need. Okay, so you get a mark for each nibble there. 0, 0, 1. Let's look at the next question. Convert the denary number minus 13. So the trick here is to write out positive 13. So I'm going to do the same thing as above, because I want to make sure that this answer is correct. Every mark counts. How do I get 13? Don't need that, don't need that, don't need that, don't need that. I do need 8, 12, 13. So I've written out positive 13. Then flip the bits. 1, 1, 1, 1, 0, 0, 1, 0, and add 1. 1, 1, 1, 1, 0, 0, 1, 1. Okay. That should be fine. But what we want to do is just double check it, because we want to be good computer scientists. So that's minus 128 plus 64 plus 32 plus 16. So if I start off with minus 128, add 64 to it, I've got minus 64, plus 82, I've got minus 82, plus 16, I've got minus 16, plus 2, I've got minus 14, plus 1, I've got minus 13. So I've proved that I'm representing minus 13 in 2's complement. That's your best bet, just to check what you're doing. Technically, that's not part of the curriculum, but I think that's the best way of learning how to do 2's complement. A washing machine uses many different embedded systems to wash clothes. 2 functions of an embedded system. Yeah, this is a great example of an embedded system. I would lock the door. I had to fix mine the other day because I had a flooding and the sink was blocked and it was going back into the washing machine. So I had to do a hard reset on it. Lock the door. Display time left. Anything that's going to be up here. Control water temperature. Just go for the obvious ones, please. Just go for the simple, obvious ones. Computers use different types of storage. Non-volatile. Okay, so keeps its content. ROM, read-only memory, and then RAM is volatile memory. So if you turn off your power to it, you get rid of it. So why would we use non-volatile storage? It's typically used for BIOS, to store startup instructions. But you can also use it to store sort of data, programs. What else can you do? More portable. Maybe high capacity sometimes. So you can use it to store, but I think this is the best answer for BIOS startup instructions. And when the computer's powered on, so when you turn on that computer, before you get to Windows, it goes to the BIOS. State the type of secondary storage media that stores data as a sequence of pits and lands. Pits and lands are optical. So the laser looks at a pit or a land and it has a slightly different delay in the time of it, and it will know if it's a 0 or a 1. So optical media like CDs, Blu-rays, DVDs. This program is to write code. Describe how an interpreter translates. So there are 3 types of translators: compilers, assemblers, and interpreters. Okay, Python is an interpreted language. Something like C++ is compiled. Describe how an interpreter translates high-level code. Line by line is translated. Okay, so every line is translated one by one. And then you can say errors reported immediately. On a compiled language, the errors are reported at the end and everything is done in one go. So that's the difference between the two. And stops if error found. Whereas if you were compiling something in C, you literally have to wait for the whole thing to compile and then you can check if what the errors were at the very end, which could be more inconvenient. Assembly language is a low-level language. The other one is machine code, which is just zeros and ones specific to a manufacturer. Describe 2 characteristics they use: mnemonics, which are ways of, you'll use them in class for ways of remembering things, like bid mass, or every good boy deserves favour, or Sokotoa. So mnemonics, key commands, you can say hardware specific, and hardware specific, and I think that's the best one. I mean, if you've got your, think of your RAM, you might have like load, add, like when we did fetch, decode, execute. These are mnemonics, and assembly code has that in there, so it will have like load or add or sub, these kind of things in there. So you can say one instruction maps to one CPU operation. It's very close to machine code, but it's human readable. Assembly language is human readable. Very difficult to program in, but because you can is it in English, but it's very close to the hardware. Software development teams use different methods to produce robust code. Name the method that records code changes, and so an audit trail or log. Think of GitHub. So think all the different branches or different push and pulls that have been in GitHub. That's the best way to, I think, remember. One role of an operating system is to allocate memory to processes. Describe how the operating system makes use of virtual memory. This is kind of a fringe question here, but if there is a shortage of main memory, well, first of all, main memory is RAM. Secondary storage are secondary is like a hard disk drive, like magnetic, SSD, optical. So just to give context here, and what might happen is if some of this might actually be used for VRAM if there's not enough space in RAM. So I think the best way to answer this question, the operating system is going to processes not using the CPU are moved out of RAM, because there's only so much you can put in there. Like if you've got 8 gigabytes or 16 gigabytes, there's only so much you can actually store in there at any particular time. Processes moved out of RAM into secondary storage, and it's swapped back in when it's time to use. It can just like swap back in. I think that's the best way to answer this. You could also talk about paging algorithms, but this is pretty deep dive here. I think that's the best way, is to say if anything that's not being used in RAM by the CPU can be moved temporarily into the secondary storage and then moved back into RAM. File repair is a type of utility software. Explain one reason why file repair software is needed. If a file is corrupted, content can be retrieved. I think that's the best, easiest answer. Keep it simple. So sometimes, you know, I've had to recover data from, say, like an SD or a hard disk, and file repair can help with that. You know, if something's not working, if like a USB stick's not working anymore, the chances are your files are still on there. Just don't use the USB stick until you're using file repair software, because all those zeros and ones are just like they're still on there. And sometimes you can get them back. Here's a diagram of a central processing unit. So we've got our registers in our CPU. This is a CPU we're looking at, an arithmetic logic unit. We've got a clock over here. So let's have a look at the question. What are the different buses? Address bus. We've got RAM. I'm just going ahead of myself. So okay, label the components. Right, so we labeled some already, haven't we? So RAM, main memory, sometimes known as primary memory, just in case they use different wordage. That was the clock. It's outside of the CPU, usually in gigahertz. So if it's like 3 gigahertz, it'd be 3 billion operations per second. And then address bus is B. And what's A? The control unit. So that's if you learning your von Neumann architecture, fetch, code, execute, a little brush up on that. Information is protected legally in several ways. Identify the law that is broken when a person gains unauthorized access. Well, Unauthorized access is misuse of a computer. So if a teacher logged into another teacher's system to amend a student's bit of data, that would be misuse. One principle of data protection legislation is that data must be processed lawfully, fairly, and transparent. Should be. Give 3 other principles. So there are quite a few here. Data must be, I'm going to just slightly abbreviate here, kept securely, not excessive, users have right to see the data. Yeah, we do. Necessary, data must be necessary and not excessive. All right. For a specific purpose. Now, of course, companies find all sorts of ways to get data that's not all of those things, and they sell it to other data brokers, but that's what they should be doing. And they should also keep it for a finite amount of time, and you should be able to actually see the data, technically speaking. Software licensed as open source can be free of charge. Just think GitHub. One characteristic of open source. So one characteristic of open source is source code is accessible. That I can see the original source code. Can be edited. Okay, so just think GitHub. This is the best option to remember this. Can be amended and can be distributed. You could, but support is limited. Usually there's no fixed support. There might be forums, but it's not a company making a profit from you. Cybersecurity protects computer systems from harm. Explain one reason why an AUP, acceptable use policy, keeps computer systems secure. So you can just say, think about, at school, have you been asked to sign one, or has your parents been asked to sign an acceptable use policy? It's quite likely that they have. So you can say users are deterred, 1T, deterred from unsafe practices because consequences are clarified. Okay, that's a good one. Something along those lines. Okay, you can talk about rules, set of rules to keep, to keep safe or keep files safe. Identify the type of malware that attaches itself. So just think in real life, a virus needs a host. And you've got a horrible kind of virus, and it has to go onto a human cell to replicate. A worm self-propagates. So it makes copies of itself. Trojan, like Trojan of Troy, masquerades as something legitimate. Keylogger, it logs your keystrokes on your keyboard as you're typing, so you might get passwords and things like that. So a virus needs a host file. It could be a PDF or something, or a JPEG. Right. Next. A business has one office in New York and one in London. type the network needed. So a wide area network. So you'll have a LAN in London and a LAN in New York, and they're going to be connected via a WAN. So think of banks or big organizations. Network protocols govern how data is transmitted. Complete the table with the network protocol for each description. So upload and download of files is FTP. I mean, you could also technically say HTTP as well. Allows connections to a network using radio waves, Wi-Fi or Bluetooth. Allows two computers to establish a connection across a network, or TCP is the best one there. Ethernet as well. Describe the role of an ethical hacker. So an ethical hacker, you might have white hat hackers who are authorized by a company to well, they can do different things. They could like say attack a network in order to gain access, and they might be, everyone's aware that they're doing that. So white hat hackers are people who are known by the organization, but sometimes an ethical hacker, could be, what we call a grey hat hacker, sort of operating slightly in between the law, and might report it to a company once they've done it. Black hat hackers tend to be cyber criminals and using it for extortion or gain. But an ethical hacker will try and be using it for good, essentially. So they might be given a list of I think this is the best answer. They're authorized by the company, so that they're given access. Right. Given access to network. I think just to add another one. To access resources and look for vulnerabilities. Yeah, I think that's enough for this. Business employs 20 people, 6 mark. Okay. Each employee has a laptop. The business is locating to a new office building. Employers need to access resources connected to the internet. Discuss the type of network the building should install in a new building. Transmission, data, media, and network topology. I would be looking at these 2 bullet points and trying to see if I can get 3 for each when you've got questions like this. So in terms of topologies, you've got bus, star, and mesh. And I think if you can demonstrate your knowledge of those, you're easily going to get 3 marks. So you could say easy to install, but you have a positive and a negative. But because bus is the terminators, and then the computers go off like this. Backbone breaks, all computers off, which is a bit of an issue. Star, you've got like a switch in the middle and all of the computers connected to it, kind of like in a star-shaped fashion, hence the name. So that would be one for me. Where what are the advantages? So failures. Don't cause wide issues, except, and this is a minus, if switch breaks. So if this one breaks, then we've got a problem. But if it's just a cable, then all the other computers will work fine. So that's an advantage and a disadvantage. In mesh networks, you can say plenty of routing options, but expensive. So mesh is where, if you've got your computers, they're all connected with each other. There are lines to every single one of them. So there's plenty of redundancies and plenty of pathways for files to go, but they're expensive to set up. No central point of failure, and they can be hard to manage. You have to have specialized teams doing it. So that would be what they're getting at with a question like this. Do you understand your topologies? There's more than enough there to say, yes, I really understand topologies. And then we can talk about transmission media. What they're getting at here is, do you understand Ethernet, wired, Wi-Fi, and or a hybrid of both? So you can talk about copper, 100-meter range. You could maybe you could talk about wireless, Wi-Fi, obviously plus and minuses. Walls could block access. Easy to add users. You can connect from anywhere. Ethernet, reliable, secure. Minus could be the cost. That's meant to be £1. So lots of different things here. When you've got questions like this, look at the bullet points and just get to the crux of what they're asking for. They want you to demonstrate your knowledge of those two things. Okay, let's keep going. Computational thinking. Right, logic. So we need to know our and, or, and not. Not is a negator, so you've got 0, it becomes a 1, if you've got 1, it becomes a 0. Or is, you only need one side to be true for the output to be true. So if both are false, then the output's false, otherwise it's true. And both left and right, both inputs have to be true for the output to be true, otherwise they're false. So once you know those three, those are the only three you need to learn for GCSE, then the rest of it's fairly straightforward. So A, B, and C, so not S and T. So a negator, S and T, if S and T is 0, not S and T is the opposite of that, isn't it? It's going to be 1. Oh, hang on, let's just check. We're rushing through this question. Here is a partially completed truth table. The logical expression for Q is complete. Complete the truth table to give the logical expression for S. The logical expression for T. Okay, so it needs for us to identify what S would actually be. So we've got a 1 and we've got a 1. This would work if it was A and C. I should probably write that with uppercase. And C. Because 0 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. Because if it's OR, it would be 1, 0, 0, 1, 1 is 1, 1, 1 is 1. And then it would make sense if it was B or C here, because I've got 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1. Yeah, okay, that's right. So now I know what those two are. I can say not S and T. So not S, and you could just write this out if you needed to, is going to be a negator. So not S and B. It's going to be 0, isn't it? And T. So what? Not S. The opposite of that is 1. And T is 1. Not S and T is also 1. Not 0, which is the opposite, and 1 is 1. Not 0, 1 and 0. 1 and 0 is 0. 0 and 1 not S and T, not 0 and T, 0, 0. So not 0, not 0 is 1, and 1 is 1. 0, 1 is 0. A bit tricky, that one. But just be methodical. If you know your 3 logic gates, then you should be okay. Just be really careful doing that. For 3 marks, that's pretty stingy. Here is an algorithm to process data. So we've got a 2-dimensional data structure here. Let's have a look at it. What's the question? Complete the table with a line number for each traversal. Traverses the records, traverses the fields. Well, line 17 is a for each loop that will traverse each record, and then inside that we'll go to each individual field. So 17 and 19. And then there is a logic error in the code. Write the corrected line of code. So let's look at the code. So what's happening here is we have a 2-dimensional array, which I think they're calling records anyway. That's fine. We've got some global variables, and then we've got our main program for sale and sales data. So we look at a record. Total equals 0. For item in sale, so this is each one of these, total equals total plus item. Okay, so that's fine. So we're looking at each item and we're adding it to our total. So 9, 6, and then 32. If item is less than current maximum, current max equals item, well, that doesn't make sense, because what we'll be looking for is the current maximum value that we've seen. So the logic error is that it should be greater than. If the item is greater than the current max that we have, then change the current max to whatever it was. Then print for every in a for loop, so sale and total, and then finally print the current max. So it will should print out 32, which is the the maximum value that's come out. So that would be what I would put in here. You just write the line item should be greater than current max, or whatever they call it. That's the logic error there. Let's have a look at the next question. Here's an algorithm. We've got a constant, uppercase, global variables initialized with a default value integer. These are very typical of how they're laid out exam questions for Edexcel GCSE. Main program, okay, so we've got count control loop for number in range of num. So num is 6, so 6 plus, that's 7, so 1 to 7. Now that's a stop value, so we go up to but not including that value. So this will do 1, 2, 3, 4, 5, 6, and then it will stop before it gets to 7. Okay, so we've got 1, 2, 3, 4, 5, 6 things, but it won't do 7. So remainder equals num, remainder equals number, which will be our 6, divided by whatever number we're looking at. So it will start off being 1, and if the remainder of that is 0, total equals total plus number, so we add that to our total or global variable, and then finally at the end we print one thing. So let's have a little bit of trace table. There we go, here's our trace table. So let's do it. So the number to start with is number 1. That's why our for loop, our start value is number 1. And in fact we can go straight ahead and literally just put all the values we know. It will not go to 7. So that's already probably a mark for that, getting that column right. What's the remainder? 6 divided by 1. The remainder is 0. So the total equals total plus what a number is, so that's 1. Because 0 was the total at the beginning, and then we added 1 to it. Then 6 divided by 2 is no remainders, it's even, so we add that to our total. So the total already has 1 in it, and we're adding our number 2, so we've got 3 in there. Then we've got the remainder. 6 divided by 3 has no remainders, so there's also 0. We've got 3 as our total, and we're adding 3 to it, so that's going to be 6. Then finally we've got number 4, fourth loop round on our for loop. 6 modulo 4 will give 2 remainder. We've got 6 in there. So if the remainder does equal 0, we total equals total plus number. But in this case, we have not added anything to our total because the condition was not met there. So the total is still 6. 5, okay, there's 1 remainder. So num, divided by 5, 6 divided by 5. Also, we don't update our total. So that's 6. And then finally, 6 modulo 6, no remainders. And if we have that condition met, we do total equals total plus number, so we get 12. 6 plus 6 is 12. Only at that point do we print the total, which is what we have down here, and we print it out, the output. Other than that, we're not doing anything else with it. There we go. Efficiency of algorithms can be analysed. The worst case is when most comparisons are required. The best case is when fewest comparisons are required. Okay, explain the worst case for a linear search. Well, let's just have an array, and then let's just have an unsorted list. Because linear search works on an unsorted list, right? Let's say we'll, I'm going to make this easier, I'll just make them separate values. Let's say we're looking for number 6. So the worst case is that we have to start here and go all the way and iterate over each item until we find our value, which is at the end. So that is the worst case. Or you could say The actual worst case is we're looking, so let's say our target equals 7, and we don't have 7 here at all. So literally looking through all of these, it wasn't in there. So worst case scenario is if after iterating over each item from the start, our target is not found. That would be the worst case scenario. Best case for a bubble sort, list array already sorted, therefore one pass required to check no swaps were made. So even though you've got a sorted array, we still have to do a whole pass to check no swaps were needed. It won't just go, oh yeah, it's done. It still has to check every pair of numbers. So nothing was swapped. Okay, we can stop the algorithm can stop. A binary search algorithm looks for a target in a sorted array. Here is the array of numbers. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got a median number. And the trick with binary search is everything has to be sorted in ascending order already. Okay. Complete so if we were looking for a number, let's just say we're looking for 33. Just to give you an example of how this works, we would look at the median value and think, okay, everything here doesn't have our number. And then we would look at only this side, and that's our new median number, and actually 33 is exactly the one we're looking for, and it's done. So we keep halving it until we get it. Now if there's not one right in the middle, if it's like an even amount of items, you do truncating and you just look to the one to the left. So if you had 1, 2, 3, 1, 2, 3, and there's nothing like here, you look at this one. Complete the table to show the steps of a binary search to look for the number 78, which is not in the array. Let me just pause for a second. So that's not in the array. Okay, you must show the calculation of the midpoint. So I'm just going to get rid of what I was doing earlier to demonstrate how this works. So let's have a look at this. We start off looking for the median value. So the start index is 0. End index is 10. Calculation of the midpoint. Okay, so it's 0 plus 10, and then we're looking at floor division 2. So 10 floor division 2 equals 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Was it found? No, it was not. Discard lower, higher, or none. So discard lower. because we're looking for 78, and we're not to our median value. The midpoint calculation is correct. That's index 5. I was just getting confused because obviously it's going from 0. That is the midpoint, as I showed you earlier. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's the median point. So apologies for any confusion on that last bit when I drew it. So what happens is we discard the median and anything lower to it if it wasn't the number we're looking for. That's the key, and we have to create a new median. So the new median is going to be it's got to be the index 6 to 10, and then we have 6 plus 10 floor division 2, so 16 floor division 2 equals 8. So did we find the number 78? No. So we discard, and that was 99. So we want to discard basically the median plus anything higher. So I'm going to say higher. Then we're looking at 6 and 7. So 6 plus 7 modulo is floor division 2. 13 modulo 2. We truncate it, so that is 6. So index 6. Did we find it? No, we didn't. So we discard anything higher. Oh, sorry, we discard anything lower. So then finally, and we've got nothing to the left of it, 7 and 7. So 7 plus 7, 14, floor division 2 equals 7. It was not the answer we're looking for. It's not 78. So I guess we can put none here. We can't really go anywhere else. We've chopped everything else up. So that's what they're looking for there. You'll need to be aware of how binary search works and also the floor division to do that properly. And that's I think that's the last question of the paper. So good luck, and I'll see you in more videos for hopefully paper 2.